Alright, fellow escape artists, weary navigators of the daily grind. Tonight, we're not just pulling the duvet up to our chins, we're pulling up anchor on this little speck of cosmic dust we call home. We're setting a course for somewhere decidedly different. Somewhere the universe really let its freak flag fly, if flags could survive hypervelocity winds and cryogenic temperatures. We're off to meet the solar system's resident eccentric uncle, Uranus. Yes, you heard that right. And before your inner 12-year-old starts snickering, and let's be honest, it's a name that has launched 1,000 giggles and a few regrettable astronomical puns, let's just acknowledge the mild absurdity of it all. The seventh planet from the sun, a behemoth of ice and gas, named after the Greek primordial god of the sky. He probably wasn't expecting his namesake to become a synonym for, well, you know. But then, the universe has a rather unique sense of humor, doesn't it? Often dark, usually indifferent, and occasionally downright slapstick. So, find that perfectly imperfect spot, the one your body knows as a signal for surrender. Let the weight of the day, with its endless notifications, its petty tyrannies of the urgent, its magnificent capacity for minor irritation, begin to unspool. Imagine those worries as little lead weights, and with each outward breath, one by one, they just detach. Plink, plink. Floating away into the vast, uncaring, and frankly, quite refreshing emptiness we're about to traverse. Because where we're going, your overdue bills, that awkward conversation, the persistent fear that you left the stove on, none of it registers. Not even as a blip. It's rather liberating, isn't it? To be so thoroughly irrelevant in the grand scheme of things. A truly underappreciated form of therapy. Tonight, our destination is a world that took cosmic nonconformity and elevated it to an art form. A planet that apparently looked at the orderly procession of its solar system siblings, all spinning more or less upright like well-behaved tops, and thought, no thank you, I'll take a nap. Uranus, the planet that orbits the sun lying on its side, like a celestial daredevil who tripped at the starting line of the cosmic race and just decided to roll with it. Literally. This isn't just a slight lean, a jaunty tilt like Earth's, giving us our charmingly predictable seasons. Oh no. Uranus is practically horizontal, its axis tilted by a staggering 98 degrees. Imagine Earth deciding to spin with the North Pole pointing directly at the sun for a few decades. Carnage. Utter, unmitigated, barbecued then flash-frozen carnage. Thankfully, we're just visiting Uranus in our minds, where the dress code is comfortable and the atmospheric pressure is always manageable. We are preparing for a voyage to an ice realm, a place of profound cold and ethereal, if somewhat standoffish, beauty. It's a journey that requires us to shed not just our physical location, but our terrestrial expectations. Out there, the rules are different. The colors are different. The very passage of time feels stretched, diluted, almost alien. Think of it as a mental palate cleanser, a way to experience a state of being so utterly removed from our own that it can't help but grant perspective. Or at least a wry smile at the sheer, baffling variety the universe has cooked up. As we begin this gentle drift, feel the last vestiges of earthbound tension easing from your shoulders, your jaw, the tiny muscles around your eyes. We are moving now, not with the brute force of rockets, but with the quiet insistence of thought, the effortless glide of imagination. The familiar blues and greens of our home world are receding, shrinking to a precious marble, then a bright spark, then just another point of light among countless others. There's a peculiar comfort in that too. Our dramas, our triumphs, our existential angst, all contained on that fading dot. Out here, in the deepening silence, the universe unfolds in its own majestic, unhurried, and occasionally alarming way. We are heading towards a whisper of a planet, a pale aquamarine jewel hanging in the deep velvet of space. A world that doesn't shout for attention like Jupiter with its raging storm, or flaunt its accessories like Saturn with its dazzling rings. Uranus is more subtle, more enigmatic. It's the strong, silent type of gas giant, if silent can be applied to a place with winds that could strip flesh from bone, and strong implies the kind of gravity that would turn you into a rather unattractive pancake. But from a safe, imaginary distance, it's a vision of serene, chilly grandeur. Our vessel is peace, our fuel is curiosity, and our only luggage is an open mind, ready to embrace the spectacular, the frigid, and the frankly bizarre. We are leaving behind the clamor and the clutter, the heat and the hurry. We are venturing into the quiet, the cold, the immensely slow dance of the outer solar system. The rules of day and night, of summer and winter as we know them, are about to be comprehensively rewritten, if not entirely shredded and tossed into a cryogenic abyss. So breathe deeply. Settle in. The invitation to the ice realm has been extended and accepted. Let the journey to the tilted oddball, the solar system's magnificent, baffling, and utterly unconcerned eccentric, begin. The silence out here is already starting to feel different, isn't it? Almost like it's listening. Or more likely, doesn't even know we're here. Perfect. And so we drift. Leaving the inner solar system feels like stepping out of a bustling, sun-drenched courtyard into a vast, shadowed cathedral. The sun, our magnificent, life-giving star, begins its slow retreat. From this vantage point, it's no longer the dominant, blazing orb that dictates our days. It's shrinking, becoming a particularly brilliant, fiercely intense diamond, but a diamond nonetheless, its warmth diminishing with every silent million miles we traverse. The light it casts out here is thinner, sharper, somehow more honest. It doesn't flatter. It simply reveals. And what it reveals is the sheer, gobsmacking emptiness of it all. An emptiness punctuated by distant, glittering stars that seem impossibly far, impossibly cold. It makes you appreciate the cosmic huddle of our terrestrial neighborhood, doesn't it? Mars, Venus, even Mercury, they suddenly feel like cozy, nearby cottages. Out here, the neighbors are few and very, very far between. This is the long, cold commute. There's no hyperjump, no convenient wormhole to zip us across the unfathomable distances. We're taking the scenic route, the slow boat, because the journey itself is part of the acclimatization. Our minds need to adjust to the scale, to the quiet, to the pervasive, deepening chill that seeps into the imagination. Imagine the temperature dropping, not in a way that makes you shiver, but in a way that makes the very concept of warmth feel like a distant, half-forgotten dream. The vibrant, chaotic energy of the inner planets gives way to a slower, more deliberate rhythm. We pass the asteroid belt, that cosmic rubble field, a graveyard of planetary ambitions, its inhabitants tumbling silently through the void, each one a potential bringer of either new worlds or abrupt, spectacular annihilation. Cheerful thought that just the universe reminding us that creation and destruction are two sides of the same very old coin. Further out still, we glide past the colossal domain of Jupiter, that striped behemoth, a king in its own gaseous court, its great red spot a swirling, centuries-old hurricane that could swallow Earth whole without so much as a burp. We feel its immense gravitational presence, a subtle tug, a reminder of the unseen forces that sculpt and govern this vast celestial dance. Even from afar, it's a humbling sight, a powerhouse of a planet. But it's not our destination. We're bound for stranger shores. Then comes Saturn, the jewel of the solar system, with its iconic, breathtaking rings. Even from this distance, they shimmer, a delicate, almost impossibly intricate structure of ice and rock, spinning in silent, frozen majesty. For a moment, we might be tempted to linger, to bask in that pale, reflected sunlight. It's beautiful undeniably. But Saturn, for all its grandeur, is relatively conventional, isn't it? It spins upright, it has distinct seasons, it plays by most of the planetary rules. Our target is the rule breaker, the one that dances to the beat of a different cosmic drummer, possibly one that's fallen over and can't get up. As we leave Saturn behind, the sun dwindles further still. It's now just the brightest star in a sea of stars, its dominion over light and heat significantly curtailed. The colors out here are muted. The vibrant reds, yellows, and blues of the inner planets are replaced by deeper, more somber tones. The blackness of space itself seems more profound, more absolute. It's a cold that's less about temperature and more about distance. A distance from warmth, from life, from the familiar. It's the kind of cold that invites introspection, perhaps a touch of existential pondering. Are we there yet? Not quite. Uranus is famously shy, lurking in the dim outer reaches, not one to show off. We begin to appreciate just how far out Uranus really is, both literally and figuratively. It's the 7th planet, and the jump in distance from Saturn to Uranus is immense, almost doubling the span we've already covered from the Sun. It's a gap so vast that for centuries, Uranus remained hidden in plain sight, mistaken for a faint star, its planetary nature unsuspected. It took William Herschel in 1781 with his homemade telescope to finally spot this celestial outlier and realize it was something more. Something different. One can only imagine his surprise. Oh, look, another star. Wait a minute. That one's moving? And it's a bit fuzzy and greenish. The universe loves a slow reveal. This leg of the journey is a meditation on space itself. Not the exciting, warp-speed, laser-filled space of fiction, but the actual, mostly empty, incredibly large space that separates everything from everything else. It's a space that breeds a certain kind of humility. Our grandest ambitions, our loudest declarations, they all fade to insignificance out here. The universe, in its vastness, simply doesn't notice. And there's a strange comfort in that, isn't there? A release from the pressure to be important. We are but tiny specks, on a tiny vessel of imagination, drifting through an immensity that defies easy comprehension. And that's perfectly all right. The light is now incredibly faint, a pale, ghostly illumination. The silence is no longer just an absence of sound, but a presence in itself. It's the silence of deep space, cold, ancient, and utterly pervasive. We are entering the realm of the ice giants, where the building blocks of planets were less rock and metal, and more frozen gases, slushy ices. Things get weird out here. The physics gets extreme. And the sense of being truly, profoundly away from it all becomes palpable. Our destination is close now. The long, cold commute is nearing its end. And the first hints of a pale, enigmatic blue are beginning to resolve themselves against the black. Prepare for your first proper introduction. It's going to be tilted. And there it is, hanging in the void like a polished, serene aquamarine bead. Our first proper glimpse of Uranus. It doesn't burst into view with dramatic fanfare. It emerges slowly, subtly from the darkness, as if reluctantly allowing itself to be observed. There's an understated elegance to it, a cool, aloof beauty. It's not the dazzling sapphire of Neptune, its more distant ice giant sibling, nor the turbulent, stormy visage of Jupiter. Uranus is quieter, more enigmatic. Its color is a delicate, almost milky blue-green, the shade of a tropical lagoon glimpsed through a layer of morning mist, if that lagoon were unimaginably vast and colder than liquid nitrogen. As we draw closer, the most striking, the most utterly defining characteristic slaps us in the face with the gentle force of a cosmic paradox. This planet is lying down on the job. Its rivals spin with a certain upright, dignified posture, their poles pointing roughly up and down relative to their orbital plane. Uranus, however, seems to have tripped over a cosmic ottoman and decided to just stay there. Its rotational axis is tilted by an almost comical 98 degrees. To put that in perspective, Earth's axial tilt, the source of our seasons, is a modest 23.5 degrees. Uranus is essentially rolling around the sun on its side like a colossal, icy barrel. One pole will point almost directly towards the distant sun for a significant portion of its orbit, then decades later the other pole gets its turn. It's a celestial arrangement that screams, "I do what I want." From our vantage point, this extreme tilt gives Uranus an utterly unique presentation. We're not looking at its equator in the conventional sense. Depending on where it is in its 84-year orbit, we might be looking almost directly down at one of its poles, or seeing its equator presented vertically like a colossal, spinning wheel. Imagine trying to play a game of celestial marbles with this one. It would be maddening. The planet itself appears remarkably smooth, almost featureless from a distance. Unlike Jupiter with its swirling bands and monstrous storms, or even Saturn with its subtle cloud patterns, Uranus often presents a face of serene, uniform blueness. This isn't to say it's a calm world, far from it, as we'll discover. But its visible cloud tops are deep, veiled by a thick, hazy atmosphere that scatters sunlight in a way that produces its signature aquamarine hue. It's the methane in its upper atmosphere that absorbs red light and reflects blue and green, giving it this cool, spectral glow. It's a color that feels inherently cold, distant, almost otherworldly. Peaceful, in a very, very frozen kind of way. We are now close enough to discern that this isn't just a static, painted orb. It is rotating, though its day is surprisingly short for such a behemoth, about 17 Earth hours. But because of its extreme tilt, this rotation combines with its leisurely 84-year orbit to create seasons unlike anything we can readily comprehend. Seasons where the sun might not set for decades over one pole, while the other languishes in an equally long, frigid night. We'll delve into that particular brand of meteorological madness later. For now, we just observe this sideways wanderer, this serene blue disk, hanging in space at its utterly unapologetic near 90-degree tilt. There's a profound stillness about it, viewed from this safe haven of our imagination. It glides through the blackness with an unhurried grace, its peculiar orientation a silent testament to a violent past or a unique formative process. The faint, distant sunlight catches its curve, highlighting its spherical nature, but the light is so weak out here, it doesn't sparkle or dazzle. It illuminates softly, like moonlight on a frozen lake. It's a beauty that doesn't try to impress, it simply is. Think of the sheer lonely majesty of it. No nearby, bustling planetary neighbors to gossip with. Just the cold, silent vacuum and the incredibly distant pinprick of the sun. It's a world that seems content in its solitude, in its eccentricity. It doesn't conform, it doesn't explain itself. Just rolls on. There's a certain admirable quality to that, isn't there? A kind of planetary stoicism. Yes, I'm tilted. Your point is. As we hover here, suspended in the velvet darkness, taking in this first full view, allow the image to imprint itself on your mind. The soft, cool aquamarine. The impossible, almost defiant tilt. The sense of immense distance and profound quiet. This is Uranus, the solar system's beautiful, baffling oddity. It's not a place that invites casual visitation. It's not cozy. It's not warm. But it is undeniably compelling, a testament to the universe's boundless creativity, its capacity to produce wonders that stretch the very limits of our understanding and our imagination. It makes you wonder what other cosmic eccentrics are out there, spinning in ways we haven't even dreamed of yet. Probably some that spin backwards while simultaneously juggling their moons and whistling a jaunty, silent tune only dark matter can hear. The universe is just that weird. This initial encounter is one of quiet awe. The kind of awe that doesn't make you gasp, but makes you fall silent, contemplating the sheer scale and strangeness of it all. It's a reminder that our earthly perspective is just one very limited viewpoint. Out here the rules are different. And Uranus, in its serene, sideways glory, is Exhibit A. So, the multi-billion-dollar question, cosmically speaking, is, why the dramatic lean? Did Uranus just wake up one primordial morning and decide that verticality was overrated? Did it lose a bet with Neptune? The universe, as usual, is a little tight-lipped about its ancient history, preferring to leave intriguing and sometimes terrifying clues scattered about like cosmic breadcrumbs. The leading theory for Uranus's extreme axial tilt is, to put it mildly, rather violent. It involves a catastrophe of almost unimaginable proportions, a colossal impact or perhaps a series of impacts early in its formation. We're talking about something big, something planet-sized, a rogue protoplanet, a massive celestial wanderer, careening through the chaotic nursery of the young solar system, delivering a devastating, world-altering blow. Imagine the scene billions of years ago. The solar system is still a construction site, full of debris, half-formed planets, and a distinct lack of health and safety regulations. Young Uranus, still gathering itself, a swirling ball of gas and ice, is just minding its own business, aspiring to be a regular, upright citizen of the planetary community. Then out of the darkness comes this behemoth. The collision wouldn't have been a gentle nudge. It would have been an event of such cataclysmic energy that it's difficult to truly comprehend. The kind of impact that doesn't just leave a crater, but fundamentally reorients the entire planet, sending it spinning like a toppled skittle in a cosmic bowling alley. Makes your worst Monday morning feel like a walk in the park, doesn't it? The energy released would have been immense, likely turning much of the young Uranus into a seething, molten ice soup, its atmosphere blasted away and reformed. It's a stark reminder that the serene beauty we see today can be born from unimaginable violence. The universe isn't always gentle watercolors and soothing nebulae. Sometimes it's a Jackson Pollock painting executed with planetoids and a complete disregard for the canvas. This great cosmic knockover wasn't just a minor fender bender. It was a full planetary reset, a testament to the universe's occasionally brutal redecorating habits. If this theory is correct, then Uranus's peculiar tilt is a scar, a permanent reminder of a truly terrible day in its very, very long youth. Of course, science loves alternatives, and there are other, slightly less dramatic, but still pretty dramatic, theories. Perhaps a series of smaller, but still significant, impacts did the job incrementally. Or maybe there were complex gravitational interactions with other giant planets, or even a large, since-ejected planetary sibling that torqued Uranus over time. Some theories even suggest that a large moon, subsequently destroyed or absorbed, could have played a role in tilting the planet through tidal forces. The truth is, we don't know for sure. Uranus holds its secrets close, veiled in those serene, methane-rich clouds. But the giant impact hypothesis remains the front-runner, largely because it's hard to get that much tilt without a very big push. A very, very big push. The kind of push that makes you grateful for the relative stability of our own dear Earth, which, despite its own tumultuous past, managed to stay mostly upright. Good old reliable Earth. Think about the sheer forces involved. The kinetic energy of a planet-sized object moving at orbital speeds. The shockwaves reverberating through the young Uranus. The subsequent reshaping of its internal structure, its magnetic field, even the orbits of its forming moons. It's a beautiful, if terrifying, illustration of celestial mechanics at its most extreme. The silent, graceful roll we observe today is the long, slow aftermath of that ancient chaos. It's like watching a perfectly spun top that was kicked at the moment of its creation, now condemned to wobble its way through eternity. Or perhaps not condemned. Perhaps it's found a new, unique equilibrium, a different kind of dance. This primordial violence also helps explain some of Uranus's other oddities, like why it radiates so little internal heat compared to Jupiter, Saturn, and Neptune. Those other gas giants are still noticeably warm from their formation, like slowly cooling embers. Uranus, however, is surprisingly cold, emitting only slightly more heat than it receives from the distant sun. One idea is that the colossal impact that tilted it also blasted away much of its primordial heat, or perhaps caused a massive internal restructuring that allowed its heat to escape more rapidly into space. So, not only did it get knocked sideways, it got its cosmic pockets picked of its warmth. A truly rough start in life. You almost want to give it a celestial blanket and a warm drink. If such a drink could exist at -200 degrees Celsius. So, as we gaze upon this sideways giant, remember that its serene appearance belies a history of profound upheaval. It's a survivor. A testament to the resilience of planetary bodies, or perhaps just their inability to complain about cosmic injustices. This isn't just a tilted planet, it's a monument to one of the solar system's most spectacular and violent fender benders. It's a story written in the language of gravity and momentum, a story of creation through near destruction. And it makes our own daily drama seem wonderfully, refreshingly insignificant. Someone cut you off in traffic? At least a rogue planet didn't sideswipe your entire world and leave you spinning for eternity. Perspective, it's a wonderful thing. Especially when delivered from the cold, impartial depths of space. Now, let's try to wrap our Earth-acclimatized minds around what this extreme tilt means for the concept of a day and year on Uranus. If you thought your Monday dragged on or that winter seemed to last forever, Uranus would like a word. Or rather, it would just silently, coldly outdo you by several orders of magnitude. Its year, the time it takes to complete one orbit around that distant, shrunken sun, is about 84 Earth years. 84 years. Imagine waiting that long for your birthday. The cake would be challenging. But it's not just the length of the year that's mind-boggling. It's how that axial tilt, that 98-degree lean, turns the seasons into something out of a surrealist painting. Because Uranus is essentially rolling on its side for a significant portion of its orbit. One of its poles points almost directly towards the sun, while the other is plunged into continuous, utter darkness. And when I say significant portion, we're talking about roughly 21 Earth years. 21 years of unbroken daylight at one pole, and 21 years of unrelenting night at the other. That's not a season, that's an epoch. Think about it. A summer that lasts for 2 decades, where the sun, however dim and distant it may be, never sets. It just circles lazily around the sky, a pale ghost light in an aquamarine heaven. And concurrently, on the opposite side of the planet, a winter of equal duration, a profound, starlit darkness unbroken by even a hint of dawn for 21 long, cold, silent years. It redefines a long winter's nap into something more akin to a cryogenic coma. So, if you were an extremely hardy, pressure-resistant, methane-breathing inhabitant of a Uranian pole, you'd experience approximately 42 Earth years of continuous daylight, followed by 42 Earth years of continuous darkness, as the planet completes one half of its orbit. Let that sink in. 42 years of sunshine, 42 years of night. Your entire working life, your children growing up, entire human generations passing on Earth, all during a single, unending Uranian polar day, or a single, unending Uranian polar night. It makes the 6 months of daylight and darkness at Earth's poles seem like a fleeting moment, a mere blink. What about the equator, you ask? Surely things are more normal there? Well, normal is a highly relative term in the Uranian context. During the periods when the poles are having their extreme solstices, the equatorial regions would experience rapid day-night cycles. Since Uranus rotates on its axis once every 17 Earth hours, an observer at the equator would see the dim sun rise and set in that time frame. But it wouldn't be a familiar sunrise. The sun would appear to rise almost vertically from the horizon, travel in a relatively low arc across the sky, and then set again, all while the overall season is dictated by which pole is currently hogging the sunlight. Then, as Uranus continues its leisurely orbit, there are the equinoxes. These occur when the planet is side on to the sun, meaning the sun is shining directly over its equator. During these periods, which also last for many Earth years, the entire planet would experience something more akin to a regular day-night cycle, with the sun rising and setting roughly every 17 hours. But even this normal is profoundly alien. The sun would be tracing a path across a sky that is, from our perspective, sideways. It's as if the entire celestial sphere had been tipped over. Imagine the psychological impact of such extreme seasonal cycles. The sheer monotony of decades of unrelenting light, or the profound, crushing weight of decades of unbroken darkness. How would life, if it could even hypothetically exist in such an environment, adapt? Would creatures hibernate for 42 years? Would they migrate vast distances across the planet, chasing the fleeting sunlight, a journey that would take generations? It's a fascinating, if chilling, thought experiment. The rhythms of life, as we understand them, are so deeply entwined with the daily and yearly cycles of our own planet. Uranus offers a glimpse into a reality where those rhythms are stretched to almost unimaginable lengths. The weather patterns driven by these bizarre seasons are also likely to be extreme. While Uranus appears visually calm from a distance, particularly during its solstices when one hemisphere is uniformly heated, however weakly, and the other is uniformly frozen, this apparent tranquility is deceptive. As the seasons change, as the sunlight shifts from one hemisphere to the other over decades, massive atmospheric disturbances are thought to be stirred up. Imagine the slow, inexorable creep of dawn after 42 years of night, or the equally slow fading of light into a decades-long twilight. These transitions would unleash colossal storms, winds whipping at hundreds of miles per hour, as the atmosphere struggles to redistribute the minimal solar energy it receives. It's weather on a truly epic geological timescale. You wouldn't just check the forecast for the weekend, you'd check it for the next decade. And you probably wouldn't like what you see. Chance of planet-encircling superstorms with a 40-year accumulation of, well, who knows what accumulates out here? Probably regret. So, as you settle deeper into your own comfortable darkness, a darkness that will, mercifully, give way to dawn in a matter of hours, not decades, spare a thought for the inhabitants of Uranus. Not that there are any as far as we know. And frankly, given the conditions, they'd have to be a special kind of masochist to set up shop there. But just imagine it, 42 years of day, 42 years of night. It makes our own seasonal grumble seem rather quaint, doesn't it? It's a stark reminder of the sheer variety of conditions the universe can throw at a planet, and how our own normal is just a tiny, privileged sliver of what's possible. Sleep well, knowing your night will be blessedly short. Let's now gently peel back the outermost layer of this enigmatic aquamarine giant, to explore the very air, or rather the non-air that cloaks Uranus. When we speak of its atmosphere, we're not talking about anything remotely breathable, of course. This isn't a roll down the windows and enjoy the breeze kind of place, unless your idea of a pleasant breeze involves being flash frozen, crushed, and then possibly blown away at speeds that would make a Category 5 hurricane look like a summer zephyr. So, maintain your safe, imaginary distance and let's just appreciate it aesthetically, shall we? The beautiful, serene blue-green color we observe, that signature Uranian hue, is primarily a trick of the light, orchestrated by the planet's atmospheric composition. The main players are hydrogen, making up about 83% of the atmosphere, and helium, accounting for around 15%. These are the primordial gases, the most abundant elements in the universe, leftovers from the Big Bang itself, diligently hoovered up by young Uranus as it formed. So far, so standard for a gas giant. But the ingredient that gives Uranus its distinctive cosmetic touch, its celestial makeup, is methane. Only about 2% methane, but that's enough. Methane gas is a rather talented absorber of red and orange light from the sun. So, when the faint sunlight penetrates the upper atmosphere, the methane molecules gobble up the red wavelengths, and what gets scattered back out into space for our distant viewing pleasure are the blues and greens. It's like a planetary scale color filter, creating that cool, ethereal, aquamarine glow. A simple bit of atmospheric chemistry really resulting in a rather lovely, if deceptively placid facade. But don't let that calm uniform color fool you. While Voyager 2 during its 1986 flyby saw a largely featureless ball, more recent observations with advanced telescopes like Hubble and the Keck Observatory have revealed that Uranus's atmosphere is far from static. It does have weather. And it's Uranian weather, which means it's big, it's cold, and it lasts for an absurdly long time. Scientists have detected vast cloud systems, some stretching for thousands of miles, swirling within that blue-green haze. These are not fluffy white water ice clouds like Earth's. These are likely clouds of methane ice crystals, ammonia ice, and possibly even hydrogen sulfide ice further down. Yes, hydrogen sulfide, the stuff that gives rotten eggs their charming aroma. So, not only is it frigid and crushing, it probably stinks on a planetary scale in certain layers. Another reason to appreciate our remote viewing experience. And then there are the winds. Oh, the winds of Uranus. They are, to put it mildly, vigorous. We're talking speeds of up to 560 miles per hour, that's over 900 kilometers per hour. These are not gentle breezes ruffling your hair. These are winds that could rip apart any conceivable spacecraft, winds that howl across a landscape, if you can call a sea of superpressurized gas and ice a landscape, with unrelenting ferocity. These winds are driven by the planet's internal heat, minimal as it is, and the complex interplay of its rapid rotation and those bizarre decades-long seasons. Imagine windburn at -200 degrees Celsius, delivered at near supersonic speeds. Not a spa treatment you'd recommend. One of the enduring mysteries about Uranus's atmosphere is why it appears so much more bland or featureless compared to Jupiter and Saturn with their prominent belts and zones, or even Neptune, which shows dramatic dark spots and bright cloud features. Part of the answer might lie in its extreme cold. The deeper you go, the colder it gets, and many of the chemical compounds that might create more colorful clouds on Jupiter or Saturn simply freeze out and sink to lower, unseen depths on Uranus. Its visible atmosphere might be just the very top, very cold, very hazy layer, like looking at a deep ocean through a thick layer of mist. The real action, the more dynamic and colorful weather systems, might be happening far below, hidden from our view. Or perhaps its internal heat engine is just more sluggish, leading to less vigorous convection and therefore fewer prominent surface features. It's the strong, silent type, taken to an atmospheric extreme. And that hazy quality is quite literal. The upper atmosphere contains layers of photochemical smog, created as sunlight interacts with methane and other hydrocarbons. This smog contributes to the planet's muted appearance and likely plays a role in its temperature profile. It's a cold, ethereal, slightly smoggy, incredibly windy and probably quite smelly place. Home sweet home it is not. So, as we float here, gazing at that pale aquamarine disk, remember that the serene beauty is a veil. Beneath it lies a realm of extreme temperatures, crushing pressures, and winds that defy earthly comparison. The whispers of methane are what paint its face, but the frozen air, if you could call it that, is a tempestuous, hostile environment. It's a good reminder that in the universe, beauty and brutality often go hand in hand. Or rather, atmosphere and atmosphere. The universe doesn't really care about our comfort levels. It just does its thing, whether that thing is painting a lovely blue sphere or trying to flay you with cryogenic winds. All part of the service. Now breathe in your own wonderfully oxygen-rich, gently moving, pleasantly non-toxic air, and appreciate the sheer, unadulterated luxury of it. Uranus certainly isn't offering any upgrades. Now summon your courage, but keep your cozy, imaginary pressure suit firmly sealed. We're going to take a hypothetical plunge, a gentle descent, not into madness, though some might argue the semantics, but into the depths of Uranus. We've admired its atmospheric face. Now let's dip our toes, metaphorically speaking, into what lies beneath those serene, methane-tinted cloud tops. Spoiler alert, it gets weird. And squishy. And very, very crushy. As we sink below the visible cloud layer, that hazy veil of methane ice crystals and photochemical smog, the temperature and pressure begin to climb. Rapidly. Remember, Uranus is an ice giant. The giant part is self-explanatory. It's about 4 times wider than Earth. The ice part, however, isn't ice in the way you might picture a snowball or an ice cube. We're talking about a vast, deep mantle composed of ices in the astronomical sense. Water, ammonia, and methane, but not in their familiar frozen forms. Instead, they exist in a strange, hot, incredibly dense fluid state due to the immense pressures. Think of it as a colossal, planetary-scale slushy, but a slushy that would instantly vaporize you, then crush your component atoms into exotic new configurations. So, perhaps not the most refreshing kind of slushy. The upper atmosphere, where we saw those 560 miles per hour winds, gradually transitions into this deeper, denser region. There isn't a solid surface like on Earth. You wouldn't land on Uranus, you'd just sink, and sink, and sink. The further we descend, the more a Geiger-esque, alien quality the environment takes on. The pressure mounts relentlessly. Thousands of times Earth's atmospheric pressure. Then hundreds of thousands. Then millions. This is a realm where familiar states of matter cease to exist. The hydrogen and helium from the atmosphere become so compressed they behave more like liquid metals. The icy mantle of water, ammonia, and methane becomes a bizarre, supercritical fluid, neither truly liquid nor gas, but possessing properties of both and hot, despite the planet's cold exterior, due to the incredible compression. Imagine floating, or rather being squeezed through this progressively denser, darker, and more hostile environment. The faint sunlight that painted the upper clouds aquamarine is long gone. We are in a realm of absolute blackness, pierced only by the occasional flash of lightning from colossal, deeply buried storms, if such phenomena can even manifest in these exotic conditions. The term ocean comes to mind, but it's an ocean unlike any on Earth. An ocean thousands of miles deep, not of water, but of these super-pressurized, exotic ices. It's a crushing embrace, a pressure so intense it would warp the very structure of atoms. Our imaginary journey, thankfully, comes with invincibility shields. Otherwise, this part of the tour would be unpleasantly brief and end with a small, dense smear of former storyteller. Scientists believe that this vast, slushy, electrically conductive mantle is where Uranus's strange, off-kilter magnetic field is generated. We'll get to that particular oddity later, but it's born from the churning, convective motions within this deep, icy fluid layer. So, while it might seem inert from the outside, the heart of Uranus is a dynamic, churning, high-pressure cauldron. And what's at the very center? What lies beneath even this immense ocean of exotic ices? The current thinking is that Uranus, like the other giant planets, probably has a core. But even the nature of this core is debated. It's likely relatively small, perhaps only about the mass of the Earth, and composed of rock and perhaps some metallic elements. But rock, at these pressures, might not resemble any rock we know. It would be compressed to incredible densities, subjected to temperatures of thousands of degrees Celsius, not from nuclear fusion like a star, but purely from the immense gravitational pressure of the overlying layers. It's less a core and more a cosmic anvil, the point where the squeezing simply cannot continue any further. So, this dive deep into Uranus reveals a world of layers, each more extreme and alien than the last. From the frigid, windswept upper atmosphere of hydrogen, helium, and methane, down into the vast, hot, superpressurized ocean of fluid ices, and finally perhaps to a small, rocky core enduring unimaginable conditions. It's a journey from a deceptively calm blue-green facade to a hellish interior that defies easy description. The term ice giant sounds almost quaint, almost gentle. The reality is a maelstrom of physics pushed to its limits. It's a good place to visit in your mind, and an even better place to leave promptly. This internal structure is what makes Uranus Uranus. It's not just a big ball of gas like Jupiter or Saturn, which are mostly hydrogen and helium all the way down. The significant component of heavier elements like oxygen in water, carbon in methane, and nitrogen in ammonia, in its mantle is what earns it the ice giant classification, distinguishing it from the gas giants. It's a different beast altogether, formed further out in the colder regions of the early solar system where these icy compounds were more plentiful. And it's this internal structure that ultimately dictates its appearance, its weather, its bizarre magnetic field, and even its surprisingly low internal heat emission. It's a planet that invites you to look deeper, and then immediately makes you glad you're only looking with your imagination. The pressure down there, it's enough to give your very atoms anxiety. Let's gently reascend, shall we, before our imaginary vessel starts to creak ominously. Having braved the crushing depths of Uranus's icy mantle, at least in our minds, let's talk about something a little more sparkly. Something that sounds like it's straight out of a cosmic fairy tale, or perhaps a particularly ostentatious display of wealth by a galactic oligarch. I'm talking, of course, about diamond rain. Yes, you heard correctly. Deep within the high-pressure, high-temperature environments of ice giants like Uranus and its neighbor Neptune, scientists theorize that it literally rains diamonds. Now, before you start packing your space mining equipment and booking a one-way trip, which, as we've established, would be a spectacularly bad idea for numerous, flesh-pulverizing reasons, let's unpack this glittering, if somewhat inaccessible, phenomenon. The theory goes like this. We know Uranus's atmosphere and mantle contain a significant amount of methane, CH4. Methane is a hydrocarbon, meaning it's made of hydrogen and carbon atoms. Deep inside the planet, perhaps around 6,000 miles down, the pressures are millions of times greater than Earth's atmospheric pressure, and temperatures soar to thousands of degrees Celsius. Under these extreme conditions, the methane molecules are thought to be literally squeezed apart. The intense pressure breaks the chemical bonds, separating the carbon atoms from the hydrogen atoms. The hydrogen, being lighter, likely floats upwards or forms other compounds. But the carbon atoms, now free and under immense duress, find each other. And what happens when carbon atoms are subjected to extreme pressure and high temperatures? They form diamonds. So, picture this. Deep within the turbulent, churning, supercritical fluid mantle of Uranus, tiny carbon atoms, liberated from their methane prisons, are crushed together, crystallizing into solid diamonds. These newly formed diamonds, being denser than the surrounding fluid, would then slowly begin to fall, to sink deeper into the planet, like glittering hailstones in a bizarre high-pressure storm. Diamond rain. It's a phrase that conjures up images of breathtaking beauty, a shower of brilliant, multifaceted gems cascading through the crushing darkness. A spectacle hidden from any possible eye, a treasure trove beyond any pirate's wildest dreams, occurring on a planetary scale. It's the universe showing off its alchemical prowess, turning simple gas into the hardest known natural substance. Now, these aren't necessarily going to be the perfectly cut, engagement ring-worthy diamonds you see in a jeweler's window. They might be smaller, perhaps more like industrial-grade diamonds, or even nano-diamonds. But diamonds they would be. And they would rain down, continuously, through thousands of miles of this exotic mantle, eventually, perhaps, accumulating into a thick layer around the planet's core. Imagine a core of rock and metal, possibly encrusted with a layer of diamonds many miles thick. A planet with a heart of stone, wrapped in a blanket of pure, crystallized carbon. It's an almost poetic image, isn't it? Born from conditions that would annihilate us in an instant. The universe, as always, has a flair for the dramatic, and a rather dark sense of humor about accessibility. Behold, infinite diamonds. But there's a slight catch regarding retrieval. This theory isn't just wild speculation. Scientists have managed to replicate the conditions thought to exist deep inside ice giants in laboratory experiments. Using powerful lasers to create shock waves in plastics, which also contain carbon and hydrogen, they've observed the formation of tiny nanodiamonds. This experimental evidence lends significant support to the idea that diamond formation is not just possible, but likely within Uranus and Neptune. It's a beautiful example of how laboratory work on Earth can help us understand processes occurring on distant, inaccessible worlds. We can't go there to scoop up the diamonds, yet give humanity a few centuries and a severe lapse in judgment, but we can recreate a tiny piece of Uranus in a lab and watch the magic happen. Of course, this diamond rain isn't just a pretty, if unseeable, phenomenon. It could also play a role in the planet's energy budget. As these diamonds form and sink, they would release gravitational potential energy as heat. This could contribute in a small way to the internal heating of the planet, although it doesn't seem to be enough to explain why Uranus is so much colder internally than Neptune, which is a similar size and composition and also likely has diamond rain. Uranus, it seems, is just particularly good at keeping its cool or perhaps losing its heat. Maybe it's just more modest about its internal bling. So, while you can't exactly frolic in these diamond showers, or expect to find a Uranian lost Dutchman mine, the very idea adds another layer of wonder, and a touch of the surreal, to this already strange and distant world. It's a reminder that the universe is full of exotic materials and processes that we are only just beginning to understand. Diamonds from heaven or hell, depending on your perspective on pressures that can forge them, a glittering spectacle born from conditions of unimaginable violence and crushing force. It's nature's way of saying, you think you've seen opulence? You ain't seen nothing yet. But you also can't have any of this. Enjoy the thought, though. The universe, the ultimate tease. And as you drift towards sleep, perhaps you can imagine that gentle, silent, and utterly inaccessible rain of diamonds, falling endlessly through the dark, deep heart of a distant, tilted world. A rather more soothing image than, say, a rain of hydrogen sulfide. Our journey around the serene, yet secretly tumultuous, Uranus wouldn't be complete without acknowledging its supporting cast, its retinue of rings and moons. Now, when you think of planetary rings, Saturn immediately springs to mind with its broad, bright, undeniably spectacular system, the supermodel of planetary accessories. Uranus, in keeping with its more understated, almost Gothic persona, also has rings, but they are the celestial equivalent of a delicate, antique, black lace choker compared to Saturn's flamboyant diamond tiara. They are faint, they are dark, and they were only discovered in 1977, quite by accident, when astronomers were observing Uranus pass in front of a distant star. They noticed the starlight dimming briefly multiple times, before and after the planet itself occulted the star. Voila! Rings. The universe, always with the subtle hints. Uranus possesses at least 13 distinct rings. Unlike Saturn's bright, icy rings, which are highly reflective, Uranus's rings are composed of extremely dark particles, probably a mixture of water ice and radiation-processed organic compounds, making them some of the darkest objects in the solar system. They absorb most of the sunlight that hits them, which is why they are so difficult to see. Some particles are boulder-sized, perhaps up to several meters across, while others are mere dust. They are also remarkably narrow, some only a few kilometers wide, which is quite different from Saturn's broad, sweeping structures. It's a more delicate, almost ethereal system. Imagine them as fine, charcoal gray ribbons encircling that pale aquamarine globe, a subtle, shadowy adornment. The origin of these dark rings is still a bit of a puzzle. Perhaps they are the remnants of a small moon or multiple moons that strayed too close to Uranus and were torn apart by its tidal forces. A rather grim end, but a common enough fate for celestial bodies that don't respect personal space. Or maybe they were formed from debris kicked up by impacts on its existing moons. Whatever their origin, they add another layer of quiet mystery to this tilted giant. There's a certain melancholy beauty to them, these dark, ghostly circles, perpetually orbiting in the frigid twilight so far from the sun, less bling, more brooding. And then there are the moons. Uranus has at least 27 known moons, and true to its eccentric nature, it doesn't name them after figures from Greek mythology, like most of the other planets. No, Uranus, breaking with tradition, or perhaps, its discoverers breaking with tradition on its behalf, names its moons after characters from the works of William Shakespeare and Alexander Pope. So, instead of Ganymede or Callisto, we have Titania, Oberon, Umbriel, Ariel, and Miranda, along with Puck, Cordelia, Ophelia, Juliet, Desdemona, and a whole tragicomic cast of literary figures frozen in icy orbit. It's a rather poetic, if somewhat incongruous choice. Imagine tiny, frozen worlds, tumbling through the darkness, bearing the names of doomed lovers and mischievous sprites. One wonders if there's a Hamlet moon out there, perpetually procrastinating its orbit. These moons are mostly small, icy bodies, mixtures of rock and ice, heavily cratered from eons of bombardment. The five largest, Titania, Oberon, Ariel, Umbriel, and Miranda, are substantial enough to be spherical, or nearly so. Miranda is perhaps the most fascinating and visually startling of the bunch. When Voyager 2 flew past, it revealed a surface that looked like it had been smashed to pieces and then haphazardly reassembled. It boasts vast canyons, some 12 times deeper than the Grand Canyon, towering cliffs, and jumbled terrains of old and new surfaces, all crammed onto a world only about 300 miles in diameter. One feature, Verona Rupees, is a cliff face estimated to be up to 12 miles high. If you were an incredibly foolish and ill-equipped astronaut standing on the edge and you jumped off, it would take you over 10 minutes to reach the bottom due to Miranda's low gravity. Plenty of time to reconsider your life choices. And the view. The origin of Miranda's bizarre, patchwork appearance is debated. Perhaps it was shattered by a massive impact and then reaccreted, or maybe it experienced some form of intense internal geological activity, with upwellings of icy slush reshaping its surface. Whatever the cause, it stands as a testament to the violent and dynamic processes that can shape even small, icy worlds in the cold outer reaches of the solar system. It's like Uranus's own little Frankenstein's monster of a moon, beautiful in its stark, broken ruggedness. These moons and rings exist in a complex dance with Uranus and with each other, governed by gravity and the planet's peculiar, tilted orientation. They orbit above Uranus's equator, meaning their orbital plane is also tilted at that extreme 98-degree angle to the planet's orbit around the Sun. So, from our perspective on Earth, we sometimes see the ring system edge-on, making it almost invisible, and at other times, we see it more face-on, a ghostly bullseye around the planet. It's a celestial ballet, performed in slow motion in the deep freeze of the outer solar system, by a troupe of dark rings and tragically named icy moons. They are the silent courtiers to this sideways king, adding to its aura of cold, distant, and slightly sorrowful majesty. Each one a tiny, frozen world with its own story, its own scars, its own silent journey through the unending Uranian night. They don't ask for applause, only for a moment of quiet contemplation as we drift past their lonely literary domain. If Uranus's tilted spin and literary moons weren't enough to solidify its reputation as the solar system's resident oddball, then its magnetic field certainly seals the deal. It's not just a little bit quirky, it's downright bizarre, a magnetic field doing the cosmic cha-cha or perhaps a drunken waltz around the planet. Most planets with magnetic fields like Earth or Jupiter have fields that are reasonably well behaved. Their magnetic poles are roughly aligned with their rotational poles, and the center of the magnetic field is fairly close to the planet's geometric center. It's neat, it's tidy, it makes a certain amount of intuitive sense. Uranus naturally scoffs at such conventionality. Uranus's magnetic field is tilted by a whopping 59 degrees relative to its already dramatically tilted rotational axis. Let that sink in. The planet is spinning on its side, and its magnetic field is tilted again with respect to that spin. It's like a spinning top that's also got a wonky internal gyroscope, making things even more complicated. But wait, there's more. Not only is it severely tilted, but the center of this magnetic field is also significantly offset from the planet's physical center by about 1/3 of the planet's radius. It's as if the magnetic dynamo, the engine generating the field deep within the planet, isn't located in the core where you'd expect it, but is sloshing around somewhere in that icy convective mantle we talked about earlier. The result of this double tilt and offset is a magnetic field that is incredibly lopsided and tumbles chaotically as the planet rotates. Imagine trying to use a compass on Uranus. It wouldn't just point north or what passes for north on a sideways planet. It would corkscrew wildly, tracing complex, looping patterns in the sky with every 17-hour Uranian day. Navigating by magnetism would be an exercise in profound frustration, likely leading to you being hopelessly lost in a cryogenic methane haze. Not ideal. This weird magnetic geometry means that the strength of the magnetic field at the surface, the cloud tops, varies dramatically from place to place. In some areas it might be relatively weak, similar to Earth's, while in others, it could be much stronger. This creates a magnetosphere, the region of space dominated by the planet's magnetic field, that is also highly irregular and dynamic. As Uranus orbits the Sun, lying on its side, and rotates, its tumbling magnetosphere carves out a corkscrew-shaped tail behind it, interacting in complex ways with the solar wind, that stream of charged particles constantly flowing from the Sun. The generation of this magnetic field is thought to occur within that strange, electrically conductive layer of superpressurized water, ammonia, and methane ices in Uranus's mantle. The convection currents within this fluid, slushy layer, driven by the planet's internal heat, however meager, and its rotation, act like a dynamo, generating electrical currents and, consequently, the magnetic field. The fact that the field is so off-kilter suggests that the dynamo region might be relatively shallow, confined to a thinner shell within the mantle, rather than extending deep into the core as it does on Earth. Or perhaps the fluid motions themselves are just inherently more chaotic and less organized. Uranus, keeping scientists employed with its perplexing internal affairs. What does this bizarre magnetic field do? Well, like other planetary magnetic fields, it traps charged particles from the solar wind and from cosmic rays, creating radiation belts. However, because of the field's chaotic nature, these radiation belts are likely to be much more complex and variable than Earth's relatively stable Van Allen belts. It would be a particularly nasty radiation environment for any hypothetical spacecraft trying to orbit Uranus for an extended period. Another tick in the not a great vacation spot column. The auroras on Uranus, the equivalent of Earth's northern and southern lights, are also predictably weird. On Earth, auroras are usually confined to high-latitude regions around the magnetic poles. On Uranus, thanks to its tumbling, offset field, auroras can pop up in unexpected places, sometimes far from the rotational poles, and their shapes and intensity would likely change dramatically over the course of a single Uranian day. Voyager 2 actually detected auroral emissions during its flyby, confirming that this icy giant, despite its cold exterior, has a dynamic, energetic interaction with the space environment. They would be ghostly, ethereal light shows, painted across that aquamarine sky by invisible magnetic brushes, a fleeting, silent display of cosmic energy in a place where day and night are already profoundly strange concepts. So, Uranus's magnetic field is another layer to its planetary eccentricity, protecting nothing you'd particularly want to visit from solar radiation, and doing so in the most convoluted way imaginable. It's a testament to the fact that the universe doesn't always adhere to our neat and tidy models. Sometimes things are just messy, lopsided, and gloriously, bafflingly complex. It's as if Uranus looked at the textbook on planetary magnetism and decided to use it for kindling. Or perhaps to roll a particularly awkward cigarette. It's just another charming quirk of this distant, tilted, and magnetically mischievous world, inviting us to scratch our heads, marvel at its strangeness, and then be profoundly grateful for Earth's comparatively boring, but blessedly stable magnetic shield. Our compasses, at least, tend to point in roughly the same direction. Small mercies. For all its distant, enigmatic allure, humanity has, so far, paid only one fleeting, up-close visit to Uranus. One brief, chilly hello, in the vastness of the outer solar system. This momentous, yet tantalizingly short, encounter was courtesy of the Voyager 2 spacecraft, one of a pair of intrepid robotic explorers launched by NASA in 1977 on a grand tour of the outer planets. Voyager 1 focused on Jupiter and Saturn, while Voyager 2, after its own rendezvous with those gas giants, was nudged by Saturn's gravity onto a path that would take it past Uranus, and then Neptune. A cosmic slingshot maneuver, executed with breathtaking precision across billions of miles. It makes parallel parking seem rather trivial, doesn't it? On January 24, 1986, after a journey of nearly 9 years, Voyager 2 made its closest approach to Uranus, skimming just 81,500 kilometers, about 50,600 miles, above its aquamarine cloud tops. For a few precious hours, it was our robotic eyes and ears in this frigid alien realm. Imagine the scientists back on Earth, huddled around their monitors, hearts pounding, as the first images and data began to stream back across the immense gulf of space. Data that had taken nearly 3 hours to travel at the speed of light. It was a moment of pure discovery, a peek behind a veil that had shrouded Uranus in mystery for centuries. What Voyager 2 revealed was both expected and surprising. It confirmed the planet's basic composition, mostly hydrogen and helium, with that crucial dash of methane giving it its color. It measured the extreme cold of its upper atmosphere, a frigid -214 degrees Celsius, -353 Fahrenheit. It gave us our first close-up views of that seemingly featureless blue-green ball, which, upon closer inspection by Voyager's instruments, did show some faint cloud bands and a few subtle storm features, particularly after image enhancement. It was like finally seeing the brushstrokes on a painting that had previously appeared perfectly smooth from a distance. These features hinted at the dynamic weather systems churning beneath the hazy facade, driven by that peculiar sideways orientation and incredibly long seasons. Voyager 2 was also instrumental in discovering 10 new moons, adding to the 5 larger ones already known from Earth-based observations. These were the smaller, inner moons like Puck, Cordelia, and Ophelia, literary sprites dancing in the darkness. It also provided the first detailed images of the known moons, revealing Miranda's bizarre, fractured surface in all its patchwork glory, a sight that left geologists scratching their heads and scrambling to come up with theories for its tortured past. It was like finding a shattered teacup meticulously glued back together by a cosmic child with a very vivid imagination. The spacecraft also gave us our best look at Uranus's faint, dark rings, confirming their existence and revealing their narrow, sharply defined structure. It even discovered 2 new, fainter rings, adding to the shadowy collection. And crucially, it was Voyager 2's measurements that unveiled the true weirdness of Uranus's magnetic field, that extreme tilt and significant offset from the planet's center. Without that flyby, we might still be picturing a much more conventional magnetic setup. Instead, Uranus presented us with a magnetic puzzle that scientists are still working to fully understand. It was as if the planet winked at us and said, "You thought I was strange? You haven't seen anything yet." But the encounter was, by its very nature, incredibly brief. A few hours of intense observation, a furious burst of data collection, and then Voyager 2 was gone, flung onwards by Uranus's gravity towards its next target, Neptune. It was like speed dating a planet. You get a few tantalizing glimpses, a flood of information, and then it's over, leaving you with a universe of new questions and a profound sense of wanting to know more. What lies deeper beneath those clouds? How do those decades-long seasons truly play out? What secrets are hidden on the surfaces of those icy moons we only glimpsed? Since Voyager 2's departure, our understanding of Uranus has continued to grow, thanks to powerful telescopes like Hubble and ground-based observatories with adaptive optics. These have shown us that Uranus is more dynamically active than it first appeared to Voyager, with seasonal changes leading to the appearance and disappearance of bright cloud features and even dark spots, similar to Neptune's Great Dark Spot, though usually fainter and more transient. But these are still distant observations. There are currently no missions planned to return to Uranus. It remains a tantalizing, largely unexplored frontier in our own solar system. A pale blue enigma, visited once, briefly, and then left to its slow, sideways dance in the cold and the dark. That fleeting flyby in 1986 was a triumph of human ingenuity and curiosity. A tiny machine, built by human hands, traveling for nearly a decade across unimaginable distances to offer us a momentary window onto another world. It's a reminder that even the most distant and alien corners of our solar system are not entirely beyond our reach, if only we have the vision and the will to explore. But it also highlights the vastness of what we don't know. Uranus gave us a quick peek, a chilly hello, and then receded once more into the depths of space, leaving us with a hunger for more. Perhaps one day we'll send another emissary, a more permanent visitor, to linger in its strange, tilted system. Until then, we have the legacy of Voyager 2, a precious handful of images, a wealth of data, and a universe of questions still waiting to be answered. It's enough to make you dream of future voyages, isn't it? Just perhaps pack an extra thermal blanket. Or 7. When Voyager 2 swept past Uranus, one of the initial impressions, especially when compared to the vibrant, swirling chaos of Jupiter or the subtly banded beauty of Saturn, was that Uranus was, well, a bit bland. Almost featureless. A serene, if somewhat aloof, blue-green orb. This apparent lack of dramatic atmospheric features, particularly at the time of the flyby, which coincided with the Uranian southern summer solstice, meaning its south pole was pointed almost directly at the sun and much of the rest of the planet was either in shadow or experiencing rapid day-night changes at the equator, led to it being dubbed the featureless giant. But is it truly serene, a celestial embodiment of calm detachment? Or is it merely aloof, its more dramatic personality hidden deep beneath a veiling haze, or perhaps just expressed on timescales that make our fleeting observations seem insignificant? The truth, as is often the case in the universe, is probably a bit more complex than a simple label. Uranus's apparent blandness is partly a matter of chemistry and temperature. Its extreme cold means that many of the chemical compounds that create colorful clouds and distinct bands on warmer gas giants like Jupiter have frozen out and sunk to deeper, invisible layers. What we see is the very top of its atmosphere, a cold, hazy stratosphere primarily composed of hydrogen, helium, and that all-important methane, which scatters blue light so efficiently. It's like looking at the surface of a very deep, misty ocean. The real storms and currents might be raging far below. Moreover, Uranus lacks the strong internal heat source that powers the dramatic weather on Jupiter and, to a lesser extent, Saturn and Neptune. Those planets radiate significantly more heat than they receive from the Sun, a leftover warmth from their formation that drives vigorous convection and creates their dynamic cloudscapes. Uranus, for reasons possibly related to that ancient colossal impact we discussed, is anomalously cold internally. It radiates only slightly more heat than it absorbs from the distant, feeble Sunday. This weaker internal engine means less energy to churn up its atmosphere and create large, long-lived storms or prominent banding. It's like a simmering pot versus a furiously boiling one. The surface might appear calmer, but that doesn't mean nothing is happening underneath. However, subsequent observations, particularly from the Hubble Space Telescope and large ground-based telescopes using adaptive optics to peer through Earth's own atmospheric turbulence, have revealed that Uranus is not entirely devoid of features. As the seasons have slowly, painstakingly changed since Voyager 2's 1986 flyby, remember, a Uranian season lasts for 21 Earth years, new cloud features have emerged. Bright, high-altitude methane ice clouds, some as large as continents on Earth, have been observed, particularly as the planet approached its equinox in 2007, when the sun shone more directly on its equatorial regions. These clouds are thought to be a result of upwelling gases from deeper in the atmosphere, becoming visible as they rise and cool. Scientists have even detected dark spots, similar to Neptune's Great Dark Spot, though generally smaller and more transient on Uranus. These are likely atmospheric vortices, colossal storm systems swirling in that blue-green expanse. So, Uranus is not entirely featureless. It's just more subtle, more discreet about its atmospheric activity. Its weather seems to be strongly tied to its bizarre seasonal cycle. During the long solstices, when one pole is constantly illuminated and the other in constant darkness, the atmospheric circulation might become more stable, leading to a more uniform, bland appearance. But as the planet moves towards equinox and sunlight begins to fall more evenly across different latitudes, this can trigger more dynamic weather, stirring up those deeper layers and bringing storm systems to view. It's weather on a truly geological timescale, unfolding over decades. Our brief snapshots might not always capture it at its most dramatic. It's like judging a person's entire personality based on a single, fleeting expression. There's a certain philosophical appeal to this, isn't there? Is Uranus serene, a model of icy calm in a chaotic solar system? Or is it simply aloof, its passions hidden, its storms brewing in unseen depths, only occasionally revealing glimpses of its inner turmoil? Perhaps it's a bit of both. Its coldness and distance lend it an air of detachment, of being above the fray. Yet, the evidence of seasonal changes and intermittent storms suggests an internal life, a slow, ponderous response to the faint energies it receives. It's a planet that doesn't feel the need to show off. It exists in its own quiet, tilted way, its beauty found in its subtle hues and its profound, almost unnerving patience. This featurelessness can also be seen as a kind of cosmic minimalism. In a universe full of flamboyant nebulae, explosive supernovae, and dramatically ringed planets, Uranus offers a study in understated elegance. A simple, perfect sphere of aquamarine, hanging in the velvet blackness. There's a purity to it, a sense of immense, cold peace. Of course, this peace is entirely from our distant human perspective. If you were actually in that atmosphere, the 500 miles per hour winds and cryogenic temperatures might offer a rather different interpretation of Serene. It's a good reminder that our aesthetic judgments are often based on a comfortable detachment from the often brutal reality. The universe is beautiful, yes, but it's rarely benign. Uranus, in its quiet way, embodies this paradox perfectly. It's a world that invites contemplation, a cool, distant mirror reflecting our own search for meaning in a vast and often inscrutable cosmos. Is it calm or just very, very good at hiding its feelings? The jury, like a Uranian winter, is still out. As our imaginary voyage keeps us company with this sideways giant, let's take a moment to contemplate something that Uranus embodies perhaps more profoundly than any other major body in our solar system, save perhaps for its even more distant sibling, Neptune. Sheer, unadulterated solitude. The solitude of the seventh planet. It hangs out there in the dim, frigid frontiers, a pale blue pearl cast into an ocean of cosmic night, so far removed from the warmth and relative bustle of the inner solar system that it feels like a world apart, a hermit kingdom of ice and gas. Consider its distance. Uranus is, on average, about 2.9 billion kilometers, or 1.8 billion miles, from the Sun. That's roughly 20 times farther from the Sun than Earth is. 20 times. Light itself, the fastest thing in the universe, takes about 2 hours and 40 minutes to travel from the Sun to Uranus. So, when you look at Uranus, through a powerful telescope, of course, as it's barely visible to the naked eye even under perfect conditions, appearing as a very faint star, you are seeing it as it was nearly 3 hours ago. It's like receiving a postcard from a very, very distant relative, delivered by a very, very slow celestial mailman. This immense distance means that the Sun, our glorious, life-giving star, appears incredibly small and feeble from Uranus. It would shine with only 1/400th the intensity it does on Earth. Imagine our brilliant midday sun reduced to the brightness of a particularly dazzling star, still the brightest object in the Uranian sky by far, but providing little in the way of warmth and casting long, ghostly shadows. The ambient light level would be akin to a perpetual, deep twilight on Earth, even during those 42-year-long polar summers. It's a realm of perpetual chill, where the dominant energy source is not the distant star, but the planet's own meager internal heat and the faint glow of the even more distant stars. This isolation is not just about distance from the Sun, it's also about distance from its planetary neighbors. The gap between Saturn, the sixth planet, and Uranus is enormous, and the gap between Uranus and Neptune, the eighth planet, is similarly vast. These are not cozy next-door neighbors. They are distant acquaintances, occasionally glimpsing each other across the unfathomable emptiness of interplanetary space. There are no casual drop-ins, no borrowing a cup of frozen methane. It's a profound aloneness, a state of being that Uranus has endured for billions of years, silently tracing its tilted path through the void. Think of the human experience of loneliness. Even in our crowded world, we can feel isolated. Now, try to imagine that feeling scaled up to a planetary level. A world so far from its primary star that its light is but a pale imitation of true daylight. A world whose nearest companions are themselves remote giants, separated by gulfs of space that defy easy comprehension. There's a certain melancholy grandeur to it, isn't there? A quiet dignity in that immense solitude. Uranus isn't complaining. It just is in its cold, distant, sideways glory. This solitude also contributes to its mystery. Being so far away and so faint makes it incredibly difficult to study in detail from Earth. Even our most powerful telescopes struggle to resolve fine features. Voyager 2's brief flyby gave us our best close-up look, but it was just a snapshot. For the most part, Uranus keeps its secrets well, veiled by distance and its own hazy atmosphere. It's like a recluse who rarely answers the door, offering only fleeting glimpses to the persistent observer. This profound isolation also emphasizes the sheer scale of our solar system, which itself is but a tiny speck in the Milky Way galaxy. If Uranus feels this remote, imagine the distances to even the nearest stars. It's a humbling perspective. Our entire solar system, out to the orbit of Neptune and beyond into the Kuiper belt and the Oort cloud, is a vast, mostly empty space, with these few precious worlds scattered like lost jewels. and Uranus resides in the lonelier outer suburbs of this already sparse neighborhood. There's a strange comfort perhaps in contemplating such profound cosmic loneliness. It puts our own anxieties, our own feelings of isolation into a different context. We are social creatures hardwired for connection. But out here, in the realm of Uranus, connection is a rare and distant commodity. The planet itself seems to embody a kind of stoic self-sufficiency, a contentment with its own company. Or perhaps, it's just resigned to its cosmic fate, endlessly rolling along its tilted axis, bathed in the faint starlight, accompanied only by its dark rings and its troop of literary moons, each a tiny frozen island of solitude in its own right. As we drift here, in the quiet companionship of this distant giant, allow yourself to feel that sense of immense space, of profound stillness, of a solitude so vast it becomes almost a presence. It's not a threatening loneliness, not from our safe, imaginary perch. It's a contemplative loneliness, the kind that invites introspection and a deeper appreciation for the warmth and connection we find in our own, much closer, much more vibrant corner of the cosmos. Uranus, the pale blue pearl in an ocean of cosmic night, reminds us that even in the most profound isolation, there can be a strange and compelling beauty. A beauty that whispers of immense timescales, unimaginable distances, and the quiet, enduring majesty of a universe that is mostly wonderfully, and sometimes terrifyingly, empty. Let's engage in a little bit of cosmic anthropomorphism, shall we? A flight of fancy, a gentle projection of sentience onto this most unsentimental of celestial bodies. If Uranus could muse, if this colossal, tilted ball of ice and gas could somehow possess consciousness and the inclination for philosophical pondering, a rather large, if, admittedly, but we're here to relax and explore, not to be bound by the dreary constraints of strict biological possibility, what would its thoughts be? What would a mind born of such extreme conditions, such profound solitude, and such a bizarre orientation, contemplate as it rolls through the eons? Its perspective would be, to put it mildly, unique. For starters, its sense of time would be utterly alien to ours. With a year lasting 84 Earth years and seasons stretching for decades, patience wouldn't just be a virtue, it would be the very fabric of its existence. Our frantic, fleeting human lives, with their mayfly urgencies, would likely appear as a brief, incomprehensible flicker, if it could perceive us at all. Oh look, it might think with a slow glacial amusement, another generation of those tiny warm specks on that distant inner rock has buzzed itself into a frenzy and then vanished. How energetic. And rather brief. There would be no judgment, just a detached, chilly observation. Its view of the cosmos would be literally sideways. Imagine perceiving the universe from an axis tilted 98 degrees. The familiar constellations would be askew, the galactic plane a strange diagonal slash across its sky. Its up and down would be fundamentally different. Perhaps it would find our upright, orderly perception of the solar system rather quaint, even a bit rigid. Why do they all spin so vertically? It might wonder. Don't they know how much more interesting the view is when you're rolling? Its primary concerns, if we can call them that, would be on a scale unimaginable to us. The slow dance of its literary moons, the subtle shifts in the solar wind as it buffets its tumbling magnetosphere, the eons-long creep of its seasons, the gradual, almost imperceptible decay of its internal heat. These would be the grand dramas of its existence. The concept of weather would be a decades-long affair. It might muse, feeling a slight shift in its atmospheric currents. Looks like spring might arrive in another 10 or 15 Earth years in the northern hemisphere. Better brace for a few centuries of slightly less cold. And what of its own tumultuous past? That colossal impact that likely knocked it onto its side? Would it remember it? Perhaps not as a traumatic event, but as a defining moment, the instant its unique perspective was forged. There was a bit of a kerfuffle early on, it might recall, with a profound understatement that only a being billions of years old could muster. Things got rather reoriented. Made the view much more interesting on the whole. No PTSD for Uranus, just a stoic acceptance of cosmic billiards. Its relationship with the sun would be one of distant, almost abstract, acknowledgement. Not the intimate, life-giving bond we share, but more like a faint, guiding beacon in the darkness, a remote anchor point for its long, lazy orbit. Ah yes, the little light. Still there. Good. The subtle warmth it provides would be noted, perhaps, but not depended upon with the same desperate intensity as life on Earth. Uranus makes most of its own weather internally, however sluggishly. And what of us? Humanity? Our fleeting flyby with Voyager 2? If it registered our brief, buzzing presence at all, it might have been with a mild, detached curiosity. A tiny, shiny thing zipped past a while back. It might ponder centuries later. Made some faint noises. Seemed awfully interested in my rings for a few hours. Then it was gone. Peculiar. Wonder if it will come back before the next ice age on that little blue inner planet. Our grand explorations, our scientific breakthroughs, our existential crises, all would likely be subsumed into its vast, slow, and profoundly indifferent worldview. This imagined consciousness of Uranus would be a study in cold detachment, but perhaps not an unkind one. Just unconcerned. It has seen empires rise and fall on distant worlds, if it could see them. It has witnessed the birth and death of stars in far-flung galaxies. Its perspective is cosmic, its timescale geological. It would be content in its slow, sideways spin through eternity, a silent observer of the grand, unfolding universe. It wouldn't be lonely because the concept of company, as we understand it, would be alien. It is its own company, its own universe in a way. Its thoughts, if translated into human language, might sound like the deepest, slowest bass notes of a colossal pipe organ, resonating with the cold, ancient wisdom of the void. It wouldn't offer us answers to our burning existential questions. It would simply be the answer in its own way, a testament to the universe's capacity for the strange, the resilient, the enduring. Meaning? It might muse if prompted. The spin is the meaning. The orbit is the meaning. The cold is the meaning. Everything else is just decoration. A rather bleak philosophy, perhaps, from our warm-blooded, emotional perspective. But for a giant ball of ice and gas, billions of years old, billions of miles from the nearest cozy fireplace, maybe it's the only philosophy that makes sense. It's a perspective that, in its own strange way, can be quite liberating. If even a planet doesn't sweat the small stuff, or the big stuff, or anything really, maybe we don't need to either. Just roll with it. Sideways. Into the cold, starry night. And so, our extended, chilly sojourn with the solar system's tilted oddball draws to a gentle close. With a last lingering look at that serene aquamarine disk, its faint dark rings, and its retinue of literary moons, we begin our imaginary drift back towards the inner warmth, back towards the familiar, spinning, upright world we call home. The profound cold and the immense distances of Uranus's realm begin to recede, though the memory of its unique, sideways majesty, its quiet solitude, and its downright baffling eccentricities, will hopefully linger, a cool balm for a mind perhaps a little weary of terrestrial predictability. We carry with us a newfound appreciation for the sheer, unadulterated weirdness the universe is capable of cooking up. Uranus, with its 98-degree axial tilt, its 42-year-long winters of utter darkness and equally long summers of perpetual dim daylight, its diamond rain falling through a crushing, slushy mantle, and its magnetic field doing the cosmic Macarena, is a testament to the fact that normal is a highly localized concept. What seems bizarre to us is just another Tuesday for Uranus. And that, in itself, is a wonderfully perspective-altering thought. Our earthly dramas, our societal norms, our very perception of time and space, they are all just one particular flavor in an infinitely varied cosmic buffet. Uranus offers a taste of something truly different, something that challenges our assumptions and expands our sense of the possible. Or perhaps the gloriously impossible made real. Our journey was one of contrast. The serene, almost featureless beauty of its visible atmosphere juxtaposed with the violent, high-pressure inferno raging within. The delicate, ghostly grace of its dark rings and tiny moons set against the backdrop of a planet likely pummeled into its current orientation by a cataclysmic ancient impact. The poetic names of its moons, Titania, Oberon, Miranda, orbiting a world of such extreme, inhospitable conditions that no Shakespearean tragedy could truly do justice to the sheer, crushing indifference of its environment. It's the universe in a nutshell, isn't it? Breathtakingly beautiful, and utterly, terrifyingly unconcerned with our comfort or survival. And yet, there's a strange comfort in that stark honesty. No pretense, no false promises. Just cold, hard, sometimes glittering reality. We've touched upon its profound loneliness, its status as a pale blue pearl in an ocean of cosmic night. And in doing so, perhaps we found a new appreciation for the relative coziness of our own planetary neighborhood, the life-giving warmth of our sun, the blessedly predictable cycle of our days and seasons. Sometimes, you need to visit the far reaches of the bizarre to truly appreciate the comforts of the conventional. Though conventional is still a stretch for any planet, ours included. We're all oddballs in our own way, just some, like Uranus, wear their eccentricity with a more dramatic, sideways flair. Reflecting on our Uranian exploration, we're reminded of humanity's small, perhaps insignificant, yet strangely persistent place within this vast cosmic tapestry. Our fleeting visit with Voyager 2, a tiny robotic emissary flung across billions of miles, was a testament to our insatiable curiosity, our drive to reach out and touch the unknown, even if the unknown is a cryogenic gas giant that would obliterate us without a second thought. There's a certain beautiful absurdity to that endeavor, a cosmic Don Quixote tilting at icy windmills. And yet we do it. We explore. We question. We imagine. As we draw closer to home, feel the imagined warmth returning, the familiar gravitational pull of Earth reasserting itself. The sun grows larger, brighter, no longer a distant pinprick but a radiant, life-sustaining orb. The pale aquamarine of Uranus fades into the star-dusted blackness behind us, taking its place once more as a distant, enigmatic point of light. But it's no longer just a point of light. It's a world we've visited, a personality we've explored, a collection of fascinating paradoxes and unsettling truths we've contemplated. It has perhaps left a little bit of its chilly, tilted wisdom with us. A reminder to embrace the beautifully bizarre, to find the sublime in the strange, and to perhaps not take our own upright, orderly existence quite so seriously. After all, in a universe that contains Uranus, anything is possible. Even perhaps a good night's sleep after contemplating a 42-year-long winter. The universe really does have a peculiar sense of humor, doesn't it? And maybe, just maybe, learning to laugh or at least wryly smile along with it is the key to navigating its splendors and its terrors. So, as the echoes of Uranian winds and the imagined glint of diamond rain fade into the quiet chambers of your mind, let yourself settle completely. You've journeyed far tonight to a world that redefines different, a place where the rules are written in methane ice and tilted axes. You've contemplated seasons that outlast human lifetimes, and pressures that forge jewels in unimaginable depths. It's a lot to take in, this grand, cold, indifferent beauty. And that's the exquisite, unsettling punchline of the cosmos, isn't it? It unfurls these wonders, these mind-bending realities, these casual displays of power that could snuff us out like a candle in a hurricane, and it does so without any particular regard for our comprehension, our comfort, or our continued existence. Uranus will continue its slow, sideways roll, its magnetic field will keep tumbling, its dark rings will whisper their ancient secrets, whether we're watching or not. And there's a profound peace in that, a letting go. Our anxieties, our daily stresses, the things that loom so large in the small hours, they seem rather terrestrial, don't they, when viewed against the backdrop of a 42-year night or a rain of diamonds on a world billions of miles away. The universe doesn't offer easy answers or warm hugs. It offers scale. It offers perspective. It offers the stark, cold, beautiful truth of what is. And sometimes, paradoxically, staring into that magnificent, uncaring abyss is precisely what we need to find our own quiet center, our own small patch of peace. So let the vastness cradle you. Let the cold, distant beauty of Uranus remind you of the infinite strangeness that lies beyond our small, warm world. And let the knowledge that none of it, absolutely none of it, requires your immediate attention tonight, be the ultimate permission to rest. The universe will handle the big stuff. You just handle the drifting off. Sweet dreams, cosmic Voyager. May they be as wonderfully tilted and serenely odd as the journey we've just shared. Sleep now. The stars and Uranus will keep their silent, icy watch.